Hi ho, those in Cyberland. We're going to talk about some dynamic routing protocols today. I hope y'all are ready to enjoy this ride with us. We're going to talk about describing the roles of dynamic routing protocols and place them in the protocols in the context of modern network design. We're going to identify several ways to classify routing protocols. We're going to describe how metrics are used by routing protocols in other way to find out how they're going to do, and what type of metric types are used in those specific dynamic routing protocols. We're going to determine what an administrative distance is of a route and describe its importance in the route process, which we've kind of already talked about a little bit in previous chapters. Identify different elements of the routing table. Okay, what's the first thing? What is the function of a dynamic routing table? What do you think? Open mouth, insert foot. Come on. Dynamic routing protocols are the same thing as a static protocol, except they're dynamic means they push things. I'm pushing something to Todd, telling him, here's what I've got. Todd then tells Brent. Brent then tells me. And we kind of share information consistently. That's dynamic. Automatic. Okay? As soon as my topology changes, they get the updates. So if I add another serial WAN connection out here to another network, that I now then tell Brent and Todd, since they're both coming out my other interfaces, tell them what's happening. So that now they know if they need to send traffic to here, they got to come through me. It's kind of like what my son says. You want a piece of me? Right? Okay. You got to go through him. He comes up and then slaps himself in the head when he says it to you. He goes, you want a piece of me? Want a piece of me? I'm like, okay, kid, don't do that. If you're going to hit someone, hit someone. Don't hit yourself. But he thinks it's more fun than he'll hit himself and then he'll back up with you and then fall down on his butt, get back up and do it again. He's just too much fun. I enjoy talking about him. Of course, any parent will always enjoy talking about their kids because that's part of their life, right? What is the purpose of a dynamic routing protocol is to discover your network, maintain the updated information, choose the best path in which to send the information, and find a best path if that current path is no longer available. Those are the four primary parts or purposes of a dynamic routing protocol.
As opposed to static.
Static is, I'm still on the phone with you. You could hang up on me, but I'm still holding the phone waiting on you. Dynamic tells me that you've hung up the phone, so I hung up the phone, then I call Todd and say, hey, Todd, why did Christian hang up on me? Okay. What are the components? Well, we have routing protocol messages, right? Pretty strict. They say, how many of you are familiar with Cisco Discovery Protocol, CDP? You heard the term? I know you did because I just talked to you about it last week. Cisco Discovery Protocol is what it tells me that Brent's there, Lee's there, Cody's there, An algorithm. An algorithm is just basically a mathematical formula that says which way to go. All right. What are the advantages of static routing? Don't read the board. Tell me, what do you think? Exactly. If the only way to get to Aaron is through Cole, I have to go to Cole to get to Aaron. All right? What are some of the disadvantages of static routing? It may take me 5 hops to get to him when I could go through Kristen, who's on a T1, to get to Aaron, which is on T1, but I have 2 dial-up connections to get to Aaron if I go through Cole. So which is going to be better? Dynamic allows you to choose which path is going to be best to send your packets through. What are some dynamic protocols that we're going to talk about? We have 2 different types of protocols. We have interior gateway and exterior gateway. And inside of interior, we have link state and distance vector. All right? Y'all see this drag and drop activity? That's what you can expect on a Cisco test. You'll need to know what characteristics are what. RIP. EIGRP. Well, what do you think EIGRP and IGRP are for? What side? Just tell me. I can tell you they're not exterior. Why would they be interior? Gateway protocols. Enhanced. Interior gateway protocols. Hint, hint, hint. OSPF. ISIS, or ISIS. BGP, Border Gateway Protocol. Where do you think that's going to be? Exterior. That's your WAN connections. Interior Gateway Protocols, IGPs. Exterior, EGPs. All right. What is an autonomous system? It's just a group of routers that have one single authority. Right? That's the single authority for all these routers. It's right here. All these over here on the right have that middle one. The autonomous number is if these all routers are basically a virtual group. I put them together by an autonomous number. Does that make sense? Y'all with me, right? Hadn't lost you? Interior gateway protocols are going to be RIP, EIGRP, and OSPF. Exteriors are going to be your border gateway protocols, or BGPs. You will use an autonomous system inside your network with these to route. BGP will use it to route externally of your business. Your point of demarcation on will be a border gateway protocol. So if you're looking, let's say you do a ping to Cox from your home, and you've left your network and you're doing Wireshark and you're watching that traffic go out, you will see BGPs come up. All right. What are distance vectors versus a link state? Let's compare them. Distance vectors. Routes are advertised as vectors of distance and direction. They will give you an incomplete view of the network topology, and they generally will send some periodic updates. Are they good? Does that make you get a warm fuzzy? What about link state? Link state tells me the entire link of the entire network that I'm in that autonomous section. Updates are not periodic. Why? Because they're dynamic. Here's a link state. R2 has the database. R1 has the database. R3 has the database. And R4 has the database. If one of these links goes down, what's going to happen? They'll all know because that link's dead. Classful routing protocols. Do not send subnet mask in the routing updates. Why? Because if they're classful, you already know it. If they're classless, that means you subnetted, it will send that subnet mask so it knows how many are on that network. Make sense? Convergence. That's what happens when all routing tables are identical. They're consistent. They're not changing. Okay? What is a metric? It's your hop count. All right? A metric takes in consideration your hops. But also, it says, how many hops is it going to take me to get to point A to point B? If it takes me 5 to get over here and 3 to get over here, which route am I going to take? 3. Why? Because if I only have 30 hops for this packet, do I want to take 5 and have a chance of it going down? No, I'd rather save those extra 2, right? That's how routing decisions are made. Metrics also use bandwidth, cost, delay, load, and reliability. For example, we have 2 T1s, right? And then we have this 56K dial-up. If I have a 5 meg file, which one do I want to send it on? The metric cost, even though I have 2 hops, it's a lot lower than this 156K dial-up. And I'll show you how we do cost associations in these metric fields. Okay? A metric for each routing protocol. If you're using RIP, its metric to find which way to send it is by the hop count. And only the hop count. IGRP and EIGRP use bandwidth by default. Delay by default. So, am I going to get delayed if I go this path? And how much bandwidth do I have? It gives you a cost. Load and reliability. Okay? Then you have is and OSPF. Okay? The bandwidth, Cisco adds it in, but the cost will tell you how much is it going to cost. And think of it as in dollars. The higher the amount, the less you want to use on it, right? Load balancing. If I have R2 and I'm trying to get to PC5, right? I'll send one to R1 and one to R3 because both R1 and R3 connect to the same switch that goes to that, right? I'm load balancing. So I'm not filling one side up with more than it can handle. What's the purpose of a metric?
The best route.
To find the best path, right? The purpose of an administrative distance. Okay? The administrative distance tells you how long is it going to take me to get from here to here. From that router to that router. There's an administration distance of 90. I have an administration distance of 120. Right? So R1 and R3 aren't going to be able to talk to each other, so they have to go through number 2. If I need to get data over here from over here, what's going to happen? It's got to go through those 90 and the 120, right? That's the administrative distance that it tells you how long it's going to take to get there. Y'all can see how it's going to do it. The default administrative distances. If it's an automatically connected device, you're at 0. Static route gives you 1. An EIGRP summary route is 5. Your border gateway protocol is 20. If I'm using EIGRP, it's 90. IGRP is a 100. OSPF is 110. is 115. RIP is 120. External EIGRP, which you'll never use. You usually use external BGPs. 170, and you're not going to use an internal BGP because I won't let you. And that's 200. So which one do you want to use on your internal network? Which one would you want to use? First off, what's the first internal network or routing protocol? Huh? EIGRP, internal. Okay? Direct connects have a distance of 1. It's known as a static connection, right? Anytime you see these direct connects with the C, you know the administrative cost is what? 1. I'm sorry, direct connect is 0. Static is 1. Dynamic routing protocols. We talked about the functions. We talked about how they share information, how they update the routing tables, how they determine a best path. We talked about how you group them as either internal or external protocols. And then you have classless and classful protocols, right? We also talked about administrative distance and metrics. Any questions? Items and concerns, gripes, complaints.